Welcome to the research desk.
And we have a really critical discussion ahead of us today.
We do, because we are looking at an industry that is currently experiencing what really can only be described as a Sputnik moment. I mean, for decades, the global automotive hierarchy felt entirely permanent, You had Detroit, you had Wolfsburg, you had Toyota City. And the assumption across the entire business world was that the transition to electric vehicles would just be managed by these exact same titans.
Right, just a shift in the powertrain, but the same basic balance of power.
Exactly. We assumed it would happen on a slightly altered timeline, sure, but with the same fundamental structure. And that assumption has completely, utterly collapsed. We are now facing this central organizing premise that changes everything. The entire global auto industry is being violently reorganized around a radically new industrial logic.
Which really brings us to the core tension we need to unpack today.
Yes. And the core question we have to grapple with is this. What if the biggest threat to Volkswagen, Toyota, and GM is not China's cheap labor? What if it's not state subsidies? What if the existential threat to the legacy automakers is simply China's clock?
The pace of it all.
Right. We are seeing Chinese automakers compress the traditional 5 to 10-year vehicle development cycle down to roughly 18 months. And I am going to make the case today that this is not a temporary anomaly. It's not some reckless cutting of corners. This 18-month cycle is a permanent structural advantage. It's the manifestation of a highly evolved, durable industrial learning machine that has just fundamentally changed how a car is conceived, built, and improved.
Well, and I intend to stress test that exact premise today. Because speed in manufacturing, especially durable, incredibly complex manufacturing, is, it's almost always a double-edged sword. We have to measure this 18-month clock against the unforgiving physics of the automotive industry.
The physical reality of the machine.
Exactly. A car is not a trivial piece of consumer electronics. It is a safety-critical, highly regulated, very capital-intensive asset with multi-year warranty liabilities attached to it. So, we really have to examine whether this hyper-accelerated product logic, this compressed validation timeline you're talking about, can actually survive the brutal reality of multi-year degradation, global safety audits, and frankly, the absolute necessity of consumer trust.
You think the speed might break the balance sheet?
I think if the testing validation is too thin, the warranty economics will absolutely eventually destroy the balance sheet. So I want to look really closely today at whether this industrial learning machine is genuinely rewriting the rules of engineering physics, or if it is just a localized phenomenon that will ultimately crack under the weight of global quality demands.
Okay, to ground this reality, though, we really have to look at the data. Because the scale of what is happening completely invalidates the idea that this is just some minor disruption at the margins. Look at the numbers from February 2026.
The BYD export numbers?
Yes, BYD sold more cars overseas than they did domestically for the very first time. They pushed past 1 million overseas sales in 2025. I mean, this is not a slow creep into emerging markets. This is a massive global reorganization of market share happening in real time. And to understand how this is physically possible, we have to look at what I call the geography of speed, specifically the Yangtze River Delta ecosystem.
Which is just a totally different paradigm of supply chain management.
It's unprecedented in the modern industrial era. Within a 200-mile radius, you have an entire, complete component base. You have the raw material processors, the battery cell manufacturers, the power electronic suppliers, the software coding teams, the contract manufacturers, and the final assembly plants. They are all sitting practically on top of each other.
And I think it is important to pause here and explain exactly why that physical proximity matters so much. Because, in a digital age, we tend to assume distance is basically irrelevant.
Right, we just assume Zoom solves everything.
Exactly. We have instant communication, video conferencing, cloud-based design software. The assumption for the last 30 years has been that a supply chain can be distributed globally without a penalty. But this ecosystem proves that physical proximity is still the ultimate accelerator. Every single time a project changes hands between different organizations or crosses an ocean, You introduce friction. You introduce delay.
You're waiting on customs, you're waiting on shipping.
You're waiting on time zones. If an engineer at a legacy automaker in Detroit discovers a flaw in a power inverter, they have to document it, send it to a Tier 1 supplier, perhaps located in Mexico or Eastern Europe, wait for that supplier to retool a prototype, wait for it to be shipped back, and then retest it. That cycle takes weeks, sometimes months.
Right.
But by collapsing the physical distance, the Chinese ecosystem shrinks decision cycles from months to days. A design change that would require a European automaker to schedule a global supply chain summit can be resolved in the Yangtze River Delta by a supplier simply, putting a prototype in the trunk of a car and driving an hour down the road to test it the exact same afternoon.
That physical reality is staggering, but its true impact only becomes clear when you place it next to the legacy development cycle. I mean, the traditional 5 to 10-year timeline of the Western automakers is just entirely mismatched to this new reality.
Well, sure, but we have to acknowledge that the legacy timeline did not just evolve out of laziness.
No, of course not.
It evolved out of absolute necessity. For the last century, automotive differentiation was fundamentally mechanical. It was about the physical tolerances in a combustion engine, the hydraulic tuning of a transmission, the physical crash structures of a steel chassis. And that requires a very sequential, heavily gated process. You spend a year doing computer-aided design, then you build physical test mules.
And then you have to ship them all over the world, right? You ship those mules to Arjeplog, Sweden for extreme winter testing to see how the mechanical linkages behave at 30 below zero. Then you ship them to Death Valley for summer testing to monitor engine cooling under severe stress. You have to sequence the regulatory crash tests across 50 different global jurisdictions. You lock in your supplier contracts 3 or 4 years in advance because tooling a factory to cast aluminum engine blocks takes years. Every step is linear. Supplier A must finish before supplier B can even begin.
And that legacy pacing, which, as you said, was perfect for mechanical engineering, is disastrously slow for software-heavy systems. We've arrived at this moment of fatal mismatch. Because the defining features of a vehicle today are not mechanical. They're its advanced driver assistance systems, the ADAS.
The sensors, the cameras. Right, this is the software and sensor suite that keeps the car in its lane, manages adaptive cruise control, prevents collisions. The defining features are the battery management protocols that dictate how fast a car can charge without degrading the cells. It's the digital cockpit. It's the user interface. When these software-defined elements are the core of the product, a 5-year freeze on development is literally a death sentence.
Because the tech is obsolete before the car even launches.
Exactly. It means your product is technologically obsolete the moment it rolls off the assembly line. The legacy automakers are operating on a geological timeframe in an industry that now demands the metabolic rate of the tech sector.
But the challenge for legacy automakers is that you cannot simply run a sequential, hardware-focused organization faster. If you try to compress a 5-year mechanical process into 18 months without fundamentally changing the architecture of the car or the structure of the organization, you don't get a faster launch. You just get a broken car.
And the legacy automakers are finally realizing that. I mean, the era of denial has officially ended, and the absolute clearest proof of this is what happened with Volkswagen.
Oh, the Cariad situation?
Yes. Think about the scale, the immense capital, and the 20th century prestige of Volkswagen. This is the company that practically defined mass-market automotive engineering for generations. They have massive engineering centers, tens of thousands of the best mechanical engineers in the world, a bottomless research and development budget. So what actually happened in 2023? Think about this for a second. Volkswagen invested $700 million into Xpeng, a relatively young Chinese EV startup taking a nearly 5% stake to co-develop electric vehicles for the Chinese market. Wait, they spent $700 million just to admit they couldn't build the software themselves?
That is exactly what that deal was. It was a complete capitulation.
It was not a distressed financial play. It was a very public, very expensive admission of internal software failure. Volkswagen had spent years trying to build their own internal software division called Cariad. They poured billions into it. Billions.
But because their organizational structure was so siloed, because the hardware teams and the software teams were operating on totally different clocks, the project was plagued by massive delays.
It held up the Porsche Macan, right?
Yes. It delayed the launch of crucial flagship vehicles like the electric Porsche Macan by years. When a titan of Wolfsburg with all its historic brand prestige and global reach has to buy time from a startup just to remain viable in the software race, the old order has shattered. It is an undeniable acknowledgement that their internal clock is fundamentally broken for the modern era.
Well, and it is not an isolated capitulation either. We are seeing a massive wave of these partnerships, which really serves as corroborating evidence that the legacy model is collapsing. Look at Stellantis,
The massive conglomerate.
right? The company that owns Jeep, Fiat, Peugeot, Chrysler. They are putting Leapmotor platforms directly inside their vehicles. Nissan is deploying $1.4 billion in China specifically to develop electric vehicles for global export. The dynamic of the entire industry has shifted. The question is no longer if these legacy companies will partner with Chinese firms. The question is on whose terms these tie-ups are happening and toward what ultimate strategic end.
How do you mean?
Well, the situation reminds me of an explorer hiring a local guide. If you are a 19th century explorer venturing into an entirely new, hostile, unmapped territory, hiring a guide who intimately knows the terrain is a perfectly rational, pragmatic decision. A seasoned traveler does not surrender their expedition just by hiring local expertise. You pay the guide to help you navigate the immediate dangers.
But there is a tipping point in that relationship.
Precisely. Here is the profound danger. If the guide controls the map, provisions the food, dictates the pace, and decides the route, the power balance fundamentally changes. You are no longer the explorer. You are the cargo. If legacy automakers rely entirely on their Chinese partners for the underlying electric platform, the battery architecture, and the software stack, what exactly is the legacy automaker doing? They are stripping away their own core competencies. They are outsourcing the brain and the nervous system of the vehicle. And if you do that long enough, you simply forget how to engineer a car.
But see, that perspective, the fear of outsourcing the quote-unquote real engineering, I think it assumes that the Western definition of innovation is the only valid one. The critique we often hear in the West completely misses the point by equating real innovation exclusively with slow, laboratory-led, foundational scientific breakthroughs. There is this persistent assumption that fast iteration is somehow shallow, that it's merely derivative copying.
You're saying the engineering is actually happening on the line.
Exactly. In the context of modern electric vehicles, the bottleneck is rarely pure foundational invention anymore. The basic chemistry of a lithium-ion cell is well understood. The bottleneck is integration. It is about how quickly a company can absorb new knowledge, industrialize it, and deploy it at scale. That is the essence of the industrial learning machine. Innovation now happens before the launch, during the launch, and long after the vehicle is in the customer's driveway through real-world data collection and over-the-air updates.
Okay, but can you give a specific hardware example of that? Because software is one thing, but hardware integration is another.
Absolutely. Look at the explosive trajectory of CATL. How does a company go from relative obscurity outside of niche industry circles in 2017 to absolute, undisputed global battery dominance by 2023? It is genuinely staggering. They did not just win by making cheap cells with inexpensive labor. They won through applied engineering. They revolutionized something called cell-to-pack design integration.
We should unpack what cell-to-pack actually means because it really illustrates the difference between foundational chemistry and industrial integration. Traditionally, an electric vehicle battery is built kind of like a Russian nesting doll. You have individual battery cells. You bundle a bunch of those cells into a protective metal module. Then you take a bunch of those heavy modules and wire them together inside a massive reinforced battery pack.
Right. It's very redundant.
It is. That modular layer adds a tremendous amount of dead weight and takes up physical space that could otherwise be used for active battery chemistry. It also requires extensive manufacturing time to assemble all those intermediate housings.
Exactly. And CATL looked at that architecture and asked how to remove the friction. They engineered a way to eliminate the module layer entirely,
They figured out how to integrate the individual cells directly into the final battery pack while still maintaining the structural integrity and the thermal safety required for a vehicle. By skipping the module phase, they drastically increased the energy density of the pack, meaning more range for the driver, and they dramatically reduced the manufacturing complexity. And they moved this from a conceptual design to mass deployment at a speed the legacy industry thought was physically impossible.
Now, I acknowledge the scale and the speed of CATL's ascent. The engineering achievement of cell-to-pack is completely undeniable. But we really must look at the mechanics of how these organizations actually function. The speed you are describing requires a level of integration that borders on the monolithic. It requires an organization to control nearly every single variable in the supply chain.
And BYD is the absolute emblem of this model. I mean, BYD has roughly 900,000 employees.
Which is just a mind-bending figure.
Think about the sheer gravity of that number. It is not merely a car company. It is a sprawling industrial organism. They have vertically integrated their supply chain to an almost incomprehensible degree. They mine their own lithium. They manufacture their own batteries. They design their own semiconductors. They write their own software. They even build their own cargo ships to export the vehicles.
Right, the roll-on, roll-off ships.
Exactly, and the story of their Blade battery perfectly illustrates why this organizational structure is the ultimate advantage. A few years ago, the entire electric vehicle industry was struggling with the severe risk of thermal runaway in lithium-ion batteries. Thermal runaway is what happens when a battery cell is punctured or overheats, the internal components short-circuit, the temperature spikes instantly, and it ignites a fire that spreads to the neighboring cells, creating this catastrophic, self-sustaining inferno that is incredibly difficult to extinguish.
It is the absolute ultimate safety nightmare for an electric vehicle platform.
And how did BYD solve it? They didn't just study alternative chemistries in some isolated laboratory for 5 years while waiting for an external supplier to build a prototype. They utilized their vertically integrated structure. They developed a battery cell that was shaped like a long, thin blade. This shape inherently dissipates heat far more efficiently than traditional cylindrical or prismatic cells.
Because there's more surface area.
Precisely. But the genius was not just the shape of the cell. Because BYD controls the entire process, they aligned the cell design, the pack production, and the vehicle chassis integration simultaneously. They engineered the blade cells to be load-bearing, meaning the battery itself became a structural component of the car's frame. They solved the safety problem of thermal runaway by shrinking the distance between a scientific insight and the factory floor to almost nothing.
They processed it all at once.
Yes, it operates like a multi-threaded computer processor. While legacy automakers process their development in a single, long, sequential timeline, waiting for the battery supplier to finish before the chassis team can even begin testing, China's system processes multiple learning loops at once across every layer of the supply chain. This is why the academic theory of organizational learning is so crucial to understanding this moment. I want to anchor this argument in a specific insight that perfectly captures this reality.
Go ahead.
The firms that win are not necessarily those with the most elegant patents. They are those with the highest absorptive capacity, the ability to recognize, assimilate, and apply new knowledge at scale.
That absorptive capacity is formidable. I will not dispute the efficiency of processing development in parallel. But, and this is a massive but, absorptive capacity does not suspend the laws of automotive physics. This is where I must bring a heavy, measured dose of reality to the conversation. Autos are not smartphones.
No one is saying they are literally smartphones.
But the development ethos treats them as if they are. A smartphone glitch forces you to restart an application. The worst-case scenario is a moment of frustration. An automotive glitch at 70 miles per hour on a crowded highway is a catastrophic, potentially fatal event. A car is a safety-critical, regulation-heavy, highly scrutinized physical asset subject to immense kinetic forces. Consumers keep them for a decade or more. They retain residual value. They are exposed to extreme heat, extreme cold, salt, vibration, and moisture. The business model in the automotive industry is not just selling the vehicle on day one. The business model is quality over time.
But quality can be iterated.
Not structural quality. Speed can be incredibly seductive in the short term, but speed can also be a smokescreen for a fatal failure mode. This brings us to the concept of narrative fragility. A company can generate massive hype, impress the market at launch with incredible digital features, and achieve incredible initial sale volume. But what happens if that compressed 18-month development cycle means the long-term hardware validation gets too thin? What happens if they don't spend enough time testing for metal fatigue over 100,000 miles? If the supplier quality is fragile, the warranty economics will eventually destroy the company's balance sheet. We have seen this specific syndrome before in other industries. Think back to the early wave of low-cost Chinese consumer electronics in the early 2000s, what I call the portable DVD player syndrome.
Oh, I remember that era vividly. You could walk into any big box retailer and see walls of these devices, from brands no one had ever heard of.
Exactly. These devices hit the global market incredibly aggressively. They competed fiercely on price and feature density. They offered larger screens and more playback formats than the established Japanese and Korean brands, and they did it for half the price. They sold millions of units practically overnight. And then, a few years later, they vanished.
Because they fell apart.
They vanished. Because the defect rates were abysmal. The screens burned out, the disc lasers failed, the hinges snapped, and the internal wiring degraded. More importantly, the service infrastructure was non-existent. When the product broke, there was no customer support to fix it. They destroyed their own consumer trust. Now, I will readily concede that today's Chinese automakers are vastly more sophisticated, better capitalized, and technologically advanced than those early electronics brands. But the underlying lesson remains absolute. Speed and feature density can win you the first sale, but it will lose you the franchise if the quality systems lag behind.
But the auto industry is entirely different from cheap electronics.
The physics are different, but the economics of trust are the same. History provides a perfect counterpoint here. Let's look at how Toyota conquered the global market. When post-war Japanese automakers entered the American market, they were initially dismissed by Detroit as low-cost, fast imitators building cheap, disposable cars. But Toyota did not conquer the world through speed alone. They won by inventing the Toyota production system.
Which fundamentally changed how factories operate.
It did, because they built quality into the very fabric of their manufacturing. They empowered any assembly line worker to pull the andon cord and halt the entire production line if they spotted a defect. They treated defect prevention as a core strategic imperative, not just a final inspection step. They understood that trust in the automotive sector takes multiple model years to build, and it takes exactly one high-profile safety recall to lose. If an 18-month development cycle prioritizes software features over long-term mechanical durability, the resulting warranty claims will just bankrupt the manufacturer.
But you are applying the quality metrics and the failure modes of a purely mechanical era to a completely digital product. The paradigm is shifted entirely.
Even in a digital product, the physical hardware must survive the elements. The suspension still has to absorb impacts. The crash structures still have to protect the occupants. And this leads to an acute danger for the legacy original equipment manufacturers, the OEMs, who are currently panicking and trying to mimic this China speed. If a legacy automaker simply slaps a shorter 18-month schedule onto a bloated, heavily siloed traditional organization without fundamentally rebuilding their supplier integration and quality systems, that is not innovation. That is cosmetic acceleration.
They're just forcing a deadline without changing the process.
Exactly. It is a recipe for expensive, catastrophic failure. You cannot just mandate speed from the boardroom if the underlying engineering culture is built for a 5-year validation cycle. If the hardware team is still using legacy processes but is told to deliver in half the time, they will simply cut corners on testing. Furthermore, the hyper-integration that creates the speed in the Yangtze River Delta carries its own systemic risk: the brittleness of monoculture.
Monoculture in what sense?
In the supply team, when an entire ecosystem relies on the same dense network of suppliers, the same centralized electronics architectures, the same battery chemistries, and the same underlying open-source software assumptions, a single defect does not just affect one model. It propagates with terrifying speed across millions of vehicles and multiple brands. In a biological ecosystem, monocultures are highly susceptible to being wiped out by a single disease. In manufacturing,
A monoculture is incredibly efficient, right up until the moment a critical flaw is discovered, and suddenly every car on the road shares the exact same vulnerability.
Okay, your concerns about hardware validation are completely valid. I agree. Brakes still have to work. Crash structures still have to absorb kinetic energy according to the laws of physics. Water sealing has to hold up against rain. But you are missing the wild card that completely neutralizes the long-term risk of the 18-month cycle. The debate is no longer about fast versus careful or mechanical perfection versus cheap assembly. The wild card is that the underlying architecture of the vehicle itself has changed. We are talking about the transition to the software-defined vehicle.
The SDV.
Yes, this is what makes a speed economically meaningful and structurally defensible. When a vehicle is software-defined, the economics of quality and the mechanics of a recall change entirely. Let me give you the clearest example of this. Look at Leapmotor. Recently, they deployed a major update to their advanced driver assistance system across their entire fleet. They identified an area for improvement, coded the patch, validated it, and deployed it to the cars in a matter of hours. European rivals take weeks, sometimes months, to deploy a similar patch. Often because of their legacy electronic architecture, they cannot push the update over the air at all. They require the customer to physically schedule an appointment and bring the car into a dealership, so a technician can plug a diagnostic cable into a port under the dashboard. Let that contrast hang in the air for a moment. That is not just a quirky anecdote about a software release schedule. It is absolute proof of a centralized, unified electronics architecture.
And this is a crucial distinction to make, actually. In a traditional legacy car, you might have up to 100 different electronic control units, or ECUs. The window motors have an ECU. The braking system has an ECU. The infotainment has an ECU, and they're often provided by dozens of different suppliers using totally different code bases. They do not communicate well with each other.
Exactly. Legacy cars are essentially a mechanical frame carrying dozens of isolated proprietary computers that cannot be easily updated. But a software-defined vehicle has a centralized compute architecture. It operates more like a single, powerful computer routing commands to dumb physical actuators. Because of this, the car is no longer a static piece of hardware that begins degrading the moment it leaves the dealership lot. The car is a living platform. It can actually improve over time.
Assuming the hardware holds up.
But even if there's an integration issue, if you discover a calibration error in the battery management system that might lead to premature cell degradation, you don't issue a massive, multi-million-dollar physical recall that damages brand trust. You push an over-the-air update while the customer is sleeping in their bed. The next morning, the car is simply fixed. This completely undermines the bear case that speed inevitably leads to warranty ruin. The software agility acts as a safety net for the accelerated hardware cycle. The ultimate analogy here is the transition from feature phones to smartphones. Look at Nokia.
The classic disruption case study.
It is, but it's so perfectly applicable here. In 2007, Nokia was the unquestioned titan of the mobile phone industry. They possessed over 40% of the global market share. Their hardware was legendary. It was indestructible. They did not forget how to bend plastic or engineer a durable radio antenna or manufacture physical buttons. They lost the entire industry because Apple and Google completely reset the basis of competition. The new battleground was no longer physical durability, it was software, developer ecosystem integration, and the speed of updates. A consumer would gladly accept a phone with a fragile glass screen and a battery that barely lasted a day if it meant they had access to an app store and constant software evolution. By 2013, Nokia's phone business was functionally obsolete and sold off for parts.
The lesson for legacy automakers is chilling. You can build a mechanically flawless, good device in the traditional sense and still completely lose the industry because you no longer control the pace of iteration. If your software is static, your flawless hardware is utterly irrelevant.
Well, that is a really powerful framing, and I think it leads us directly to a synthesis of our two positions. The Nokia analogy highlights exactly what is at stake. If we look at the reality of the landscape today, China's speed is indeed a durable, terrifying advantage. But it is only an advantage when it is strictly embedded in that ecosystem control and software competence you just described. Speed by itself, operating in a vacuum without the safety net of over-the-air updates is a massive liability.
Right, it's just rushing.
Exactly. But speed paired with trust, speed paired with a centralized software architecture that allows for instant correction and continuous improvement is an absolute juggernaut. That is the stark reality the legacy automakers are waking up to. If we examine the Stellantis and Leapmotor deal through this synthesized lens, the long-term stakes become incredibly clear. This partnership is a defensible, rational bridge strategy if, and only if, Stellantis uses the time it buys to fundamentally rebuild its own internal capabilities.
To build their own car yard that actually works?
Precisely. They get immediate access to a low-cost, software-defined electric platform, which stops the bleeding in the short term and gives them product to sell right now. But if, 5 years from now, the core software stack, the centralized electronic architecture, the battery chemistry, and the platform economics still live exclusively with their Chinese partner, then Stellantis has merely managed its own decline. The legacy OEM will have hollowed itself out. They will lose the ability to engineer their own future, essentially becoming nothing more than a regional distributor slapping a heritage badge on imported technology. They will own the marketing and the dealerships, but they will not own the innovation.
That is exactly the actionable takeaway for the legacy firms. They have to protect the core software architecture at all costs. They cannot outsource the brain of the vehicle. They must build their own regional battery ecosystems to shrink their own feedback loops and replicate the physical density we see in the Yangtze River Delta. You just cannot compete on speed if your components are spending 6 weeks on a cargo ship. And while they are undertaking this massive internal reorganization, they have to compete fiercely on the exact metrics where speed is hardest to copy: brand trust, safety credibility, reliable dealer networks, and premium service experiences.
Which takes decades to establish.
Exactly. It takes decades to build the kind of consumer trust that legacy brands possess, and that is an asset they must leverage. We also have to acknowledge the geopolitical response that is unfolding right now in real time. We are seeing a wave of tariffs and trade barriers being erected across Europe and North America in response to this competitive threat. But I mean, from an industrial perspective, tariffs are largely theater.
They're a stall tactic.
They are a political tool. They might buy a few years of breathing room for domestic workforces and legacy supply chains, but they absolutely do not close the underlying productivity gap. Protectionism without rigorous internal reorganization is just a very slow, highly managed decline. The goal of industrial policy right now cannot just be to block Chinese vehicles at the port. It must be to force domestic firms to match that organizational velocity without surrendering control of the underlying technology.
And that really is the ultimate reckoning for the industry. The real threat of China's speed isn't just that cars are being assembled faster on a factory floor. It is that the very definition of what a car company is has been permanently altered. We are no longer talking about metal benders and engine tuners. The era of the mechanical stronghold is over. We are talking about integrated tech firms managing vast supply ecosystems, processing real-world data at scale, and writing millions of lines of code.
And the survivors of this transition will absolutely not be the legacy firms who just try to build cars the old way, only a little bit faster. The survivors will be the ones that learn how to iterate and absorb new technology like software companies, but remember that they must always earn consumer trust like automakers.
This is the Research Desk officially signing off.